All right, let's talk about something that's literally all around us, but we barely ever think about. All those smart devices. We're talking billions of them. And the big question is, how in the world do we make sure they're secure?
I mean, think about it for a second. What could your smartwatch, your car, and a hospital's IV pump possibly have in common? They seem like totally different worlds, right?
Well, the answer is actually pretty simple, but it's a huge deal. Every single one of them is run by a tiny, hidden computer. And no, I'm not talking about a mini laptop. These are invisible computers, totally integrated into the thing they're controlling.
So let's dive into this world of invisible computers. They're literally everywhere. And the software that runs on them? That's called firmware. And here's the kicker. Securing firmware is a massive headache. It's so tangled up with the physical hardware that finding bugs is just incredibly hard.
So, what exactly is firmware? Think about an app on your phone. It has an operating system, like iOS or Android, to handle all the complicated stuff, like connecting to Wi-Fi. Firmware doesn't have that luxury. It's on its own. It has to talk directly to the hardware, telling every little chip and sensor exactly what to do. That makes it a totally different animal when you're trying to test it for security flaws.
And that brings us to what I like to call the digital fortress problem. Imagine you're trying to find a secret weakness in a giant, heavily guarded castle. The problem is, you don't have a map, and you have no idea how to speak the language of the guards at the gate. That's pretty much what security researchers are up against here. Now, the main tool in a security researcher's toolkit is something called fuzzing. It's kind of a brute force method, really. You just throw massive amounts of random junk data at a piece of software and hope you can make it crash. Why? Because a crash usually means you found a bug. And that bug, well, that could be a golden ticket for an attacker. But here's the thing. Standard fuzzing just doesn't work for these devices. It's like, remember our fortress? Fuzzing is like just standing outside the main gate and shouting complete gibberish. The guards are just going to ignore you. Your random data never gets inside because it's not speaking their language, it's not following the rules.
And this is a great way to visualize why. When data arrives at a smart device, it's not just a simple message. It's more like a digital Russian doll. The data is wrapped in multiple layers, and each layer has its own rules. If you get the address wrong on the outermost doll, or a special code called a checksum is wrong on the next layer, and poof, the whole thing gets thrown in the trash before it ever gets to the tiny doll in the middle, which is the actual application we want to test.
And the researchers who wrote the paper we're looking at today, they don't mince words. They say that the current tools are basically stuck. They just can't build those complex, perfectly structured messages you need to even get past the first wall of the fortress.
So if a bigger battering ram won't work, what's the solution? Well, you have to be smarter, and that's where our hero comes in. Its name is Pemu, and Pemu isn't about brute force. Oh no, it's more like a universal translator, a spy with the perfect disguise.
What Pemu does is a total game changer. It doesn't try to bash down the door. Instead, it's designed to listen, to automatically figure out the secret languages, those complex network protocols that the device uses to talk to the outside world.
Okay, so how does it actually do that? How does Pemu crack the code? It really boils down to a clever three-step infiltration plan.
Step 1. Pemu listens. It pokes and prods the system with different kinds of messages and just watches to see how the firmware responds. It's learning. Step 2. It disguises the random test data from the fuzzer. It takes that gibberish and wraps it up in a perfect digital package so it looks completely legitimate. And step 3, it delivers that package. And because it looks perfect, it sails right past all those digital guards to test the important code hidden deep inside.
Okay, so this diagram might look a little complicated, but the idea behind it is actually super simple. You see, Pemu sits right in the middle. On one side, you have the fuzzer, just cranking out all that random data. On the other side, you have the firmware we're trying to test. Pemu is the brilliant translator in between, taking all that chaos from the fuzzer and making it look like a perfectly normal conversation that the firmware will actually pay attention to.
And this is the really incredible part. Pemu automates all the really annoying, tedious stuff. It figures out the correct network addresses, it calculates those checksums we talked about, it even handles the complex back and forth of a digital handshake. Basically, it does all the hard, boring work, freeing up the fuzzer to do the one thing it's good at, finding bugs.
So that all sounds great in theory, right? But does it actually work in the real world? Well, let's take a look at the results, because this is where things get really interesting. This is where we see Pemu uncovering flaws that were hidden before.
What you're looking at here is a measure called code coverage. You can just think of it as how much of the software's code the fuzzer was actually able to reach and test. As you can see, the other tools on their own, they hit a brick wall. But when you add Pemu into the mix, whoosh, the amount of code they can explore just skyrockets.
And how big a jump are we talking about? Try this on for size. For Fuzzware, which is a top-of-the-line tool, Pemu boosted the code coverage by an average of, get this, 40.7%. That is a huge increase in what researchers can actually see.
And of course, more visibility means you find more bugs. And that's exactly what happened. While they were testing it, Pemu found 5, count 'em, 5 brand new, never-before-seen security flaws. So this isn't just theory. This thing is a real-deal bug-hunting machine.
I mean, the final scorecard is just wow. It found 12 bugs that were already known, which proves it's reliable. It found 3 additional bugs that another special tool completely missed. And the best part, it plugs into existing tools and it's completely automatic. No more pulling your hair out with manual setup. So why should you care about all this? Because we're not just talking about some abstract digital fortress. We're talking about the security of our cars, our medical devices, the critical infrastructure that runs our entire world. This stuff really, really matters.
Look, a tool like Pemu is an absolutely massive step in the right direction, but it also kind of shows you just how big this problem is. And that leaves us with one final big question to think about. As our world gets smarter and more connected every single day, how do we make sure that all these invisible computers running the show are actually worthy of our trust?